Hey, welcome back everyone once again. Today we are talking about all about value at risk. Now, value at risk, or famously known as VaR, it's a very important concept not just in FRM part 1 but also throughout the FRM curriculum. And just to let you know, you have close to 4 chapters dedicated just to this value at risk in your FRM level 2. Okay, so very important. And in this particular video, I'm going to be talking about value at risk, how you interpret the value at risk. We will also look 3 ways in which you can calculate the value at risk. And in the next videos, I'm going to be uploading about the expected shortfall and coherent risk measures. So make sure that you are a part of this journey. Subscribe to our YouTube channel as well. Okay, so let's start with what is value at risk. So VaR, what it does is that it gives you an amount that you could lose on a portfolio. Okay, so VaR, as the name suggests, it is the value or the money which is at risk. Okay, so let's take a simple example. Assume that you are managing this $100 million portfolio, and your boss or your supervisor comes to you and says that what is the maximum amount of money we can lose on this particular portfolio if any bad event happens. Now, somehow you go ahead, you do some calculations and you come up with a number. Let's say you come up with $5 million, and you tell your boss that on any given day, if anything bad happens in the stock market, this is the maximum amount of money that we could lose on our portfolio. So what exactly is this amount? This is your value at risk. Okay, simple enough so far. Now let's look at the definition. Value at risk, it gives an estimated loss amount, the money that you could lose on a portfolio over a holding period and a given confidence level. Now, in every value at risk statement, you will see 3 things. The very first one is the loss amount. Obviously, we are calculating the money which is at risk on our portfolio. So the very first thing is the loss amount. The second is the holding period. Now, this amount that you quoted, is this for one day? It could be for a week. It could be for a month. It could be also for a year. So what day are you referring to? This also needs to be mentioned in every value at risk statement. Okay, and finally we will have a confidence level or some probability involved in it. Okay, are we 100% sure that this $5 million, that's the maximum amount? Anything bad happens in the stock market, is it the maximum amount that we could lose? Maybe we can even lose $10 million, maybe $20 million, perhaps even $50 million on any given day, right? So confidence level will tell us how sure are we in quoting this particular amount. Now let's look into the interpretation of value at risk. So assume that a risk manager has calculated weekly 99% VaR as $5,000. Now notice this weekly is our holding period. We are interested to calculate the VaR for a week, and the confidence level or the probability level is 99% confident. Whatever amount that we give out, I have to be 99% confident in that. Okay, so this is the probability for that. And finally, the loss amount, this is the amount that we have calculated. Okay, now we will go into more detail into the interpretation, and I can actually interpret this statement in 2 ways. The very first one, I can say in terms of confidence level. I can say that I am 99% confident, since we are calculating 99% VaR. I can say that I am 99% confident that the maximum 1 week loss will not exceed $5,000. Okay, so that's one way of saying this statement. Another way I can communicate is the minimum loss level. Now imagine out of 100%, 99% there is a probability that this amount will not exceed. But what about the other 1%? That's the room for error, right? So that's what we refer to as minimum loss level. And I can say that there's only a 1% chance that the loss will exceed $5,000 or more. Okay, so I am 99% confident this will not be exceeded, but there's a 1% chance that this can go up. Okay, so these are the 2 interpretations of value at risk. Now on your textbook you will see sometimes you will see 99% VaR, and sometimes you will see VaR at 1%. So what does this mean? Over here, all 99% VaR, 95% VaR, 90% VaR, these all represent confidence level. Okay, we are talking about the confidence level, and this VaR at 1%, VaR at 5%, and VaR at 10%, that refers to significance level or minimum loss level. Okay, let's say that if I want to calculate 99% VaR, I can say that I'm 99% confident that my VaR amount will not exceed. On the other hand, there's a room for error for 1%, so there's a 1% chance that the loss will exceed. Okay, similarly, I can say for this that I'm 95% confident that my VaR amount will not exceed. The rest 5% is there is a chance that it may exceed that amount. And finally, for 90%, I am confident about that, and 10% chance that the loss will exceed that particular VaR amount. Now, very often banks are very much interested in calculating the 99% VaR. You will hardly see 90% VaR calculation, because let's say that the 90% VaR calculated for a bank is, let's say, $100 million. So banks do not want to take chance of this 10%, right? Because there is a 10% probability that this amount may be exceeded. That's not going to be good for any banks. Amidst all these things, you must be wondering that why are we calculating this amount in the very first place? Why are we interested in calculating the loss or the minimum loss level? Well, the reason for that is this $5 million, or let's say for a bank, this $100 million will act as a buffer or the capital amount that the bank will actually keep aside. So anything that happens to the bank's portfolio, bank will have this money so that they can go ahead and they can make up for all the losses. Okay, so this is why VaR is very popular and it's used throughout finance and risk management, so that you can keep aside this money and protect the losses. Okay, now there are three ways in which we can go ahead and calculate the value at risk. The first is the historical simulation method, second is the delta normal VaR, and the third one is the Monte Carlo approach. So let's have a look at each of these methods in detail. Okay, now let's start with the very first method, and that is the historical simulation method. Now this is one of the most simplest method to calculate the value at risk, and though it's quite simple, but it's widely used and quite popular as well. Okay, so let's understand what we have in historical simulation. So essentially what we do is that we collect daily data on the behavior of risk factors over a period of time. Let's say that I am interested to find the value at risk for a particular stock, let's say ABC company. I can simply collect the historical returns data of ABC company, and I can go ahead and I can find the value at risk with that particular data. Now let's say that I have the last 20 days data of ABC Corporation, alright, and I want to calculate the VaR at 10%. I can also say it as 90% VaR, right? They both mean one and the same thing. Now when you pull up the data from the internet, you will have jumbled up returns of a particular stock, right? So in my case, I've already arranged it. So the very first step in historical simulation is arranging the data starting from the largest loss right here, and then moving down to 0, and then going all the way down to the gains right here. Okay, so this is the very first step. Then what we do is that if we are interested in calculating the 10% VaR, we just take 10% of the data that we have. So in this case, we have 20 days of historical data, so we just take 10% of that, and that is 2 days. So this is the first data point, and this is the second data point. So my VaR is just negative 6.99%. So this is my value at risk at 10% for this particular ABC company. Quite simple, right? You just arrange the data, just take the VaR, and that's it. Now continuing with the same thing, assume that I have last 500 days data of this ABC Corporation, and I want to find the VaR at 1%, or I can say 99% VaR. So what I'll do is I'll take 1% of the number of days that I have, which is 500, and the answer will be 5, right? So what I'll do is I will go ahead, I will arrange all these 500 data points in this order, starting from the largest loss and then going all the way down to the gains. So the fifth data point that I have will be my VaR. Okay, and if I have last 1000 days of returns data of this ABC Corporation, and if I want to calculate VaR at 5% or 95% VaR, I can take 5% of this data that I have 1000, and that will be 50. So all these return data, I'll first arrange it in this fashion, and then the 50th data point, that will be my VaR under the historical simulation method. Okay, right, so I've got an example here. Let's solve this thing. So assume that I've collected the daily returns data of past 1000 days of this particular stock that I have right here, and you want to compute the monthly VaR for this security at a confidence level of 95%. The value of the portfolio is $10 million. Now confidence level of 95%, that means VaR at 5%. Okay, I've got the data right here, all these different returns. Now assume that this is the 1000 data points that I have, and I have arranged this data starting from the largest losses on the left tail and moving all the way to the largest gains right here, as you can see. All right, so that's what I've arranged in the very first step of historical simulation, and then I will just calculate 5% of 1000, which would be 50th data point. Okay, so the 50th data point comes somewhere around here, and this becomes my VaR at 5%. So 15.69% is my value at risk. Now this is in percentage terms. I can just go ahead, I can take 15.69 multiplied by the asset value, which is $10 million, and I'll have my VaR in dollar terms. Okay, now there's one thing that I want you to take notice of, and that is tells you about the money that you could lose on a portfolio, right? So VaR will always be on the left side of any distribution. Okay, so VaR focuses on the left tail, and that is why VaR is sometimes also referred to as left tail losses. If I say that it's a left tail losses, that means I'm talking about the VaR, right? So remember that always and always we focus on the left tail of the distribution to get the value at risk. Okay, now let's talk about the second method, which is delta normal VaR. So far in the historical simulation, we did not assume any specific distribution, right? Whatever distribution we had, we just multiplied the VaR that we wanted to calculate and the number of data that we had, and we arrived at our VaR number. But when we talk about delta normal VaR, in this method we specifically assume a standard normal distribution. Now this makes our job very easy. We no longer have to arrange the data like we did in historical simulation. We just have a simple formula that can be used to get the VaR. So this is the standard normal distribution, and we know from our quants that in standard normal distribution we just have two parameters. The one is the mean, which is the mu, and this one is the standard deviation. Only these two parameters define the entire distribution. All right, and the special thing about standard normal distribution is that with the help of z-scores we can find any area under this curve. Firstly, what we do is that we focus on the left tail because we have losses on the left tail and gains or profits on the right tail. Okay, but for value at risk we focus only on the left tail because VaR itself tells you about the potential losses, right? So our entire focus is right here. And secondly, the z-scores that you see here, these are all the z-scores for one tail test. Now this is a very important point, guys. VaR is always a one tail test, and we have z-scores for one tail test only. Okay, make sure that you remember these z-scores for the exam. These are not for two-tailed. Okay, that's what I'm trying to differentiate. This is a one-tailed z-score. So for example, if I want to calculate VaR at 10%, I'm going to be using this 1.28 z-score. VaR at 5%, it's going to be 1.65, and VaR at 1% would be 2.33. Now let's bring the formula. We can calculate VaR with just these two parameters, mean and the standard deviation, and we have a z-score right here. Now let me explain this formula. I'm starting out with the mean, that is mu, and I'm going to the left hand side because VaR, as I said in historical simulation, we look at only the losses side, and we have the z-scores right here. Let's take an example to understand that. So assume that the return distribution of this company is normally distributed with annual mean of $16 million and a standard deviation of $10 million. Now we have the assumption that it is normally distributed. So calculate the VaR at 95% using delta normal approach. I will just plug the formula. So I have the mean here as $16 million. The negative, I have to go to the left tail. 95% VaR, that means VaR at 5%. The z-score I have is 1.65 multiplied by the standard deviation. I'm already given the standard deviation as $10 million, and I get the answer as negative $0.5 million. Okay, so this is my value at risk. As I said, VaR gives you the losses, so that is why we have this negative side. So now the third approach to calculate the VaR is the Monte Carlo approach. Now Monte Carlo simulation is much more sophisticated than the historical simulation and delta normal VaR, and in this method what we do is that we generate multiple scenarios, maybe hundreds and thousands or perhaps even millions of scenarios, by taking random samples from the distribution that we assume for the particular risk factor. Okay, so we do not use the historical data. We generate multiple scenarios and we try to simulate what can be the potential outcome. Now to calculate Monte Carlo approach VaR, we need a statistical software or perhaps Excel. Okay, but in a nutshell, I'm going to explain how it's done. Okay, so we first calculate the current portfolio value. Let's say that the current value of the portfolio is $10 million. Then we run this simulation and we find the ending value of this portfolio. So let's say that the first time I run the simulation, I have the ending value of $9.8 million. Then what I do is that I take the difference of the ending value and the current value. So in this case, it is $0.2 million. Then again, I will go ahead, simulate another ending value, and this time I get $9.9 million. So I will have the difference as $0.1 million. Then again, I will go ahead, I will calculate another ending value. I'll take the difference from this current portfolio. Now in this way, I can go ahead and I can simulate thousands and thousands of different ending values, and all these differences that I will get, this will have its own distribution, and from this distribution that I get from these differences, I will calculate the VaR. Okay, so in a nutshell, this is the entire process of the Monte Carlo approach. Okay, so the advantage of Monte Carlo is that it is able to address multiple risk factors, and you can simulate thousands of simulation. I can go ahead, I can get ending values of up to thousands, perhaps even millions. Okay, so that's the power of the Monte Carlo approach, and the main disadvantage is that the simulation with Monte Carlo is computationally intensive and it's quite slow. Okay, so this is a drawback of the Monte Carlo approach. And finally guys, we are talking about the limitations of value at risk. So now the first limitation talks about the confidence level. Now what it says is that if the confidence level goes up, the VaR level will also go up. And this is very much true, right? If 5% value at risk is around this level, then if I want to calculate VaR at 1%, it's going to be a little bit higher, right? And if I want to calculate VaR at 10%, it's going to be lower than this value, right? So as the confidence level goes up from 5 to 1%, we can see that the VaR level also goes up. All right, so that's very intuitive. The second thing we have is the holding period. Also true, if the holding period goes up, the VaR will also go up. All right, now let me explain. So let's say that the 1 day VaR is $10 million, and if I'm interested to find the 5 day VaR, then I will not go ahead and I'll multiply 10 times 5 and I'll get my VaR number. No, what we do is that we follow the square root rule, because VaR, it rises with the square root of the holding period. That means I'm going to take the square root of this holding period and multiply by the VaR that we have, and I will have my answer as $22.36 million. And similarly, if I want to find 20-day VaR, I will take the square root of 20 and multiply by the VaR 44.72. Now as you can see that the holding period is increased, the VaR also increases. Okay, so this is very intuitive as well. Okay, the third limitation is that VaR, it doesn't tell us about the magnitude of the actual loss. Now this is very, very important and one of the most important limitation of value at risk. Just have a look at this histogram right here, and you see that I've calculated my 5% VaR at 15.69%. Now just imagine if I am a risk manager or a portfolio manager, and if I'm confident that my VaR will not be exceeded, then what about this actual loss of almost 28%? Now this can be very bad for a portfolio worth millions or billions of dollars, and hence this is a major limitation of VaR, because it doesn't tell us anything about the losses beyond this VaR level. What about these losses that you see which is above the calculated VaR? And the LTCM case study is a perfect example of failure of value at risk, because they assumed their value at risk to be $320 million, and in reality they suffered a loss of over $1 billion. Can you imagine, you're just keeping this amount as a buffer and suddenly you face more than double the amount of losses in your trades. So this is a prime example of limitations of VaR, and hence we need another risk measure that can take care of these losses, and I'm going to talk about what that measure is in the next video that I'll be uploading. Okay, and finally the fourth limitation is the model risk and implementation risk. Now this goes without saying that value at risk is itself a model, right? We can have some wrong inputs, we can have some wrong methods. So model risk and implementation risk is a part of the limitations as well. So that's it guys for this video, and in the next video I'm going to be uploading about the expected shortfall and coherent and spectral risk measures. So make sure that you subscribe to our channel if you haven't subscribed yet, and thank you so much for your time today. Thank you.